Assalamualaikum and good day everyone. So let's look at learning outcome 4.2a, apply Newton's law of motion. So let's look at exercise 2, question number 1. A load of 250 kilograms is hung by a crane's cable. The load is pulled by a horizontal force such that the cable makes 30-degree angle to the vertical plane. If the load is in equilibrium, calculate the magnitude of tension in the cable and the magnitude of the horizontal force. Okay, let's try to draw the situation given by the question. So we have a crane. So let's say this is my crane. Okay. So the crane will have cable and the cable is attached to the load and the load is being pulled by a external force, horizontal external force. So this is the external force. Okay. So it is also stated that such that the cable makes 30-degree angle to the vertical plane. So if we draw a vertical plane here, so that 30-degree would be this one. Okay, now let's draw the free body diagram of the load. So I am going to represent the load with a dot. So obviously the load is experiencing external force, horizontal external force. The object, the load is on Earth, so therefore it will have weight. Okay, and we have another one here, the tension. Okay, so to determine the angle, so let's draw the y-axis here. So these two y-axis are in parallel. So therefore, if this one is 30-degree, this one would be 30-degree as well. So let's draw the axis for our free body diagram. Okay, so this one would be 30-degree. So this is your y, this is your x. So they ask you, it is also mentioned that the load is in equilibrium. So meaning to say the acceleration is 0 ms per second. The object literally is like that lah. Okay. So let's calculate the magnitude of the tension in the cable and the magnitude of the horizontal force. So for this one, we are going to treat the forces in x component and y component separately. So therefore, we have to resolve the three vectors. So let's start with force. So this is your x component. This is your y component. So for the force is acting on x component. So therefore, the y component of the external force is 0. And we have no further information about the horizontal force. So you need to find it here in part B. So just put in F, okay? So next, let's look at weight. So weight is acting along y component. So therefore, that would be weight equals to mg. Mass is given. G is 9.81. And if you look here, the weight is acting downward, so therefore we have to put the negative sign. So we are going to substitute. The mass is 250 kg. G is 9.81. Okay, so press your calculator, you get negative 2453. Okay, how about the x component of the weight? The weight is acting along y component, so therefore the Wx is equals to 0. Next force is tension. So the tension is acting here 30 degree northwest. Okay, so for this one, for Fx, it would be sorry, not F, Tx, okay? Let's be consistent with your notation. So Tx would be here, this one. So if you resolve it in x component, so it would be this one. So this is your Tx. So it would be T cos, sorry, T sine 30. Why is it sine 30? Because the position of angle is between y-axis and the resultant vector. So therefore for Tx it would be T sine 30. So the direction is to the left, so you have to include the negative sign here. So substitute T. T is what we are looking for. And sine 30 is, I'll just put here sine 30 lah. Okay, T sine 30. Okay, for y component of T, so if you resolve Ty, it would be upward. So this is your Ty. So Ty is T cos 30. Okay, so we can just leave it like that. So let's continue in finding the tension and the horizontal force. So again, it is stated that the load is in equilibrium. So therefore, summation F x equals to 0, summation Fy equals to 0. So let's try to use the y component first. So for the y component, we have summation Fy equals to 0. So let's put here 0. So on y component, we have two forces. The first one is weight. So negative 2, 4, 5, 3 plus t cos 30. So if you rearrange this, you can find your T, your tension. So your tension would be 2453 divided by cos 30. So try to press your calculator. What is your answer you're going to get? So 2453 divided by cos 30. So your answer would be, so I got here 2832.5 Newton. Okay, now let's look at what x component summation Fx equals to 0. Why is it equals to 0 again? Because in question, it is stated that the load is in equilibrium. Okay, so acceleration equals to 0. So therefore, summation Fx equals to 0. So on x component, we have two forces as well. So we have F minus T sine 30 equals to 0. So if we rearrange here and we substitute this T by we are going to substitute this T with the answer we obtained before. So that would be 2832.5 times with sine 30. So press your calculator. You are going to get, the answer is 1416.2 Newton. 1.2 Newton. Okay. So next, let's look at question number 2. Okay, for question number 2, calculate the magnitude and direction of a force that balanced the three forces acted at point A as shown in figure below. So they ask you to calculate magnitude and direction of a force that balanced the three forces acted at point A as shown in figure below. So the key word here would be balance. So what we know about balance, that would be summation f x equals to 0, summation f y equals to 0. In this question, they ask you what is another force, the direction and magnitude of another force that balances this free body diagram. Okay, so we have F4 and they are asking what is F4. Okay, so what we need to do first is we need to find what is F4x and what is F4y. Then only we can find the resultant F4. Okay, so let's do this together. So I'm going to insert the table. Please use ruler, okay, to draw the table. Okay, let's do this together. So we have F1, F2, F3, F4. So this is the X component. This is the Y component. So for F1x, let's resolve F1x. So F1x can be resolved in X and Y component. So this is Fy, this is Fx, F1, Y, F1x. So for F1x, it is to the right, so that would be positive. So it would be F1. For this one would be cos 55. So that would be 12 Newton. So I'm going to substitute straight away. So it's going to be 12 cos 55. Okay. So for F1 Y component, so this one, since the position of angle is here between X axis and the resultant vector F1, so for Fy that would be 12 sine 55. Since the direction is upward, so here is positive value. So let's look at F2. So F2 can be resolved in X and Y component as well. So this is F2Y. Sorry, F2X. This one would be F2Y. Okay. So for F2X, it is acting to the left. So that would be negative 20 cos 30 degree. Okay. For F2Y, it would be it is pointing upward, so therefore it is positive value. So that would be 20 sine 30 degree. So now let's look at F3 again. We can resolve F3 into two components as well. So this is F3Y, this is F3X. So for F3X, F3x would be, since it is to the left, so it will be negative sign. So the magnitude of F3 is 30 and the angle, so the position of angle is here. So therefore it would be cos 45 degree. And for F3y, it is acting downward, so negative sign as well. So F3 is 30. So that would be F3 sine 45 degree. So we don't know anything. We don't have any further information regarding F for X and F for Y. So let's just put it like that. Okay. So we are going to solve this using Newton's first law. So summation F x equals to 0. So on x component, we have 1, 2, 3, 4 forces. Let's start with 12 cos 55 degree plus negative 20 cos 30 degree plus negative 30 cos 45 degree plus f for x equals to 0. So press your calculator, you will get the value for f for x. Negative 20 cos 30 cos. So for this one, we have here negative 31.65 plus f for x equals to 0. So f for x is 31.65. Okay, Newton. So that is for x component. So let's look at y component. So summation Fy equals to 0. So again, we have 4 forces acting on y component. So that is 12 sine 55 plus 20 sine 30 degree plus negative 30 sine 45 plus f for y equals to 0. So let's press the calculator. 12 sine 55 plus 20 sine 30 plus negative 30 sine 45. So we have here negative 1.38 plus f for y equals to 0. So f for y is negative 1.38 Newton. Sorry, it should be positive, okay? Because you bring your negative sign to the right, okay? So that will be plus negative plus 1.38 Newton. Okay. So for the magnitude of the force, just use the formula. So summation F4 is square root F4 x squared plus F4 y squared. So for your F4 x squared, you substitute 31.65 squared plus 1.38 squared. Okay, and then you square root everything. You press your calculator. So you should get, the answer is 31.68 Newton. So let's determine the direction. So for the direction, it would be, we are going to use the formula theta equals to inverse tangent modulus f for y over modulus f for x. Okay, so press your calculator. So substitute first, okay? Tangent -1. So for f for y is 1.38 divided by 31.65 modulus, okay? So for this one, we have inverse tangent 1.37 divided by, sorry, I got here 1.38 divided by 1.68. So your answer would be 2.49 degree. Okay. So to describe the direction, you need to draw the axis. Okay, so this is your axis. So this is your x, this is your y. Okay, let's draw fx first. So fx is 31.63 positive. So fx is this one. It's acting along x-axis to the right because of the positive value of the magnitude. And for fy, that would be positive 1.38. So therefore, it should be pointing upward. Okay, so we can determine the direction of F4. The resultant force would be this one. Okay, and the angle is here. So we can describe the direction would be 2.49 degree above positive x-axis. Okay, so next, let's look at question number 3. Okay, class, for question number 3, so we have here a window washer pushes his scrub brush up a vertical window at a constant speed by applying a force as shown in figure. The brush weighs 10 Newton and the coefficient of friction is 0.125. Okay, calculate the magnitude of the force. So the normal force exerted by the window on the brush. So here they ask you two questions. So first let's draw the free body diagram. So first we have, so we are going to put the object is here, okay? So I'm going to draw the free body diagram of this thing here, okay? So what we have here, the window washer pushes his scrub brush up a vertical window. So they are exerting a force pushing the brush, okay? So if we transfer this to a free body diagram, you get something like this, okay? So that is the external force, the push force, okay? And then it says that the brush weighs 10 Newton. So this is the weight of the brush. This is the weight of the brush. So assume this is a straight line, okay? Please draw with a ruler. So this is your weight, okay? So it has another force, which is the kinetic friction force. Okay, for this case, what would be the direction of the kinetic force? Okay, so we have to determine on our own. So as I mentioned before, the direction of the kinetic force will oppose direction of motion. So if you can see here, if I push the brush like this, so in y component, in y-axis, the brush will travel upward. So therefore, the direction of the kinetic friction would be downward. So this one would be at K. Okay, let's transfer that to our free body diagram. So we have another force here, which is kinetic friction. Again, it says here constant speed. So when it is mentioned constant speed, again, the acceleration of the object is 0. So therefore, summation Fy equals to 0, summation Fx equals to 0. So now let's resolve. Okay, we haven't determined the what we call that, the angle. Okay, let's look at the triangle here. So I am going to erase the kinetic friction because I want you to see the triangle. So since this is 50 degree, so this is 90 degree. Okay, so this is 90 degree. So what will be the angle here? So this one would be 90 minus 50. Okay, which is 40 degree. Okay, 40 degree. So I am going to put here 40 degree. Because in a triangle, the total internal angle for a triangle is 180 degree. So 180 minus 90 minus 50, you will get 40 degree. So if we would like to translate the angle, let's do this. Okay, let's say this is the axis, so this is the y-axis, the x-axis. Okay, so this one would be 40 degree. So let's draw the axis of the free body diagram. Assume it is a straight line, please. So this is my x, this is my y. So this one would be 40 degree. Okay, now we can resolve the vectors. Again, y component, x component, y component, sorry. Okay, so we have how many forces? 1, 2, 3 forces. Oh, we have another force that I forgot, which is a normal force. Why do we have a normal force? Because the object is in contact with the surface, so therefore my normal force would be to the left. So this is our normal force. Okay. So we have four forces. Okay. So the first one is the external force. So the external force we can the external force can be resolved into two components, which is F sine 40. So this one would be F cos 40. By this time, you should be able to resolve on your own, okay? So make sure you have a strong basic about resolving vector. Next, let's look at weight, okay? So for the weight, for x component, the weight is acting on y component. So therefore, Wx is 0 and Wy, we have give it here, which is 10. Okay, the next force, let's look at the normal force. So we have here normal force on x component. It is acting along x component to the left. So that would be negative and okay, 0. And last but not least, we have kinetic friction force. and the kinetic friction force is acting downward. So therefore, Fkx is 0 and Fky is, so the formula for Fk is mu Kn. Okay, so we have our mu, which is 0.125. However, we don't know our normal force. Let's just put it N. So for Fk, it is acting downward, so we have to put here a negative sign. Okay, so let's try to do the resultant force to find the magnitude of force and the normal force. Okay, let's start with x component. So summation fx equals to 0. Again, why summation fx equals to 0? It is because it is stated that moving with the same constant speed, okay? Moving with a constant speed, therefore acceleration 0. So summation fx equals to 0. There are two forces acting on x component. The first one is F sine 40 minus n. So equals to 0. So you will get n in terms of f, which is f sine 40 degree. So next, let's look at your y component. So summation Fy equals to 0. So on y component, we have three forces acting on y component. So the first one is F cos 40 degree plus 10. Okay, for this 10, let's look at the direction of the weight. The weight is actually downward, so it should be negative 10. Okay, and for this one, we plus negative 0.125 n equals to 0. Okay, for this case, we can substitute our n with f sine 40. So f cos 40 degree minus 10 minus 0.125. So we are going to substitute n with f sine 40 degree equals to 0. So if you rearrange, you are going to get F equals to 14.6 Newton. Okay, so we have obtained our F. Next, what we can do is we can substitute F into with this value, so we can obtain our N. So therefore, N equals to 14.6 sine 40 degree. Okay, so for this one, you will get your answer for N is 9.39 Newton. 9.39 Newton. So this is the two answers they asked from the question. So they only asked about the magnitude. So they ask you to calculate. So therefore they are asking for magnitude. You don't have to worry about the direction. So next, let's look at question number 4. Assalamualaikum and good day everyone. So today we continue with question number 4. So the system in figure is in equilibrium with the string at the center exactly horizontal. Calculate the tension T1, T2 and T3 and angle theta. So this is the angle that we need to find out, and they ask you to find the magnitude of T1, T2 and T3. How do I know they asked me to find the magnitude? Because they use the word calculate. Okay, so we need to calculate magnitude. Okay, so when you get this type of question, first it is important for you to draw a free body diagram of the object. So we have this is okay for this case. I am going to draw a free body diagram of the center part here and another one here, okay? Okay, so what we have would be, so let's start with point orange. So this is my first point. So we have tension T2 to the right. We have T1. We have T1. And we have here another tension. I'm just going to put this one T, okay? Why I use a symbol tension? Because the weight is being um, the weight is being uh, hang here with a string, okay? So this T, the value would be equals to the weight of the object, which is 40 Newton. So the angle is given, the angle of theta is given for this one. So the angle is 35 degrees, okay? And for point green, so this is my second free body diagram. Okay, we have tension T3. We have another tension downward, and this tension is equals to 50 Newton. Okay, so I am going to put here T5, T, the tension due to weight of 50 Newton. And for this one, I'm going to change the notation to T4, okay? T40 and T50, okay? Let's be consistent with that. And then we have here another tension to the left. And the symbol is T2, the notation is T2, and for the angle here is theta. So we need to find the angle theta. Okay, let's first look at the orange one. So it says that the figure is in equilibrium. So we know that when the mention equilibrium, so acceleration equals to 0. So therefore, summation f equals to 0, no matter in x component or y component. So let's start with the orange one, the orange free body diagram. So we have summation Fy equals to 0. On y component, we have two forces. The first one is T due to weight of 40, and the other one is the y component of T1. So we have here T1y minus T40 equals to 0. So let's try to substitute. So T1y equals to T1 cos 35. Why I use cos? Because the position of angle is in between y component and the vector T1. So minus 40 Newton. So we have T1 equals to 40 over cos 35. So you are going to have cos 35, okay? So the answer for T1 would be 48.83 Newton. Okay, so this is for T1. Okay, now let's look at x component of the orange object. So summation fx equals to 0. On x component, again, we have two forces acting on x component. The first one is T2 to the right. So let's put here T2. The other one is the x component of T1. So that one would be minus T1y. Why is it minus? Because the vector is pointing to the left. So according to sign convention to the left, we should put negative sign. So T2 equals to, so if I bring my T1 here, my T1y is T1 sine 35. So we have our value of T1, which is 48.83. Just substitute 48.83 sine 35. So your answer should be 28 Newton. So my T2 would be 28 Newton. So we already have our T1 and T2. So to find T3, an angle, we have to use the free body diagram of the green color. So let's start with summation Fy equals to 0. So for green one, I am going to use green pen. Okay, so for these solutions, I am talking about the green color free body diagram. Okay. So for the y component, we have two forces. One is T2, negative T2 because it is to the left. Another one is the x, sorry, I am talking about y components. Okay, I am talking about y component. Okay, I am so sorry about that. Okay, so we are talking about y component. So y component, we are going to have the y component of T3. So we have T3y plus T negative T 50 equals to 0. So T3 would be T3y is T3 cos theta. So equals to, I am going to bring my 50 T50 to the side. So that would be plus, so equals to 50. Okay, let's leave our equation like that. Let's make T3 first as a subject. So T3 equals to 50 over cos theta. Okay, so let's do the x component of the green free body diagram. So summation Fx equals to 0. So on x component, we have two forces acting on it. So that would be negative T2 plus T3x equals to 0. So negative T2, so we have the value of T2 here, so we can substitute negative 28 plus T3x would be T3, T3, what would it be? T3 sine theta equals to 0. Okay, so again, let's make T3 as a subject. So that would be T3 equals to 28 over sine theta. So if you notice that we have two equations, we have two unknowns, so we can use both equations. So if this is the case, I am going to make 50 cos theta equals to 28 sine theta. So I am going to bring my sine up here. So sine theta over cos theta equals to 28 over 50. So if you notice here, sine theta over cos theta, we are going to have tangent theta. So 28 over 50. So theta would be inverse tangent 28 over 50. Okay, so press your calculator, inverse tangent 28 over 50. So your answer should be, the angle would be theta equals to 29.25 degree. So we have our angle, we can substitute the angle into either of these. So I am going to use T3 equals to 28 over sine theta. So the value of sine theta is 29.25. So let's substitute sine 29.25 degree. Okay. So press your calculator. You should get T3 equals to 57.31 Newton. Okay. Don't forget to put your units because we are doing physics. So for question so for question number 5, I want you to do it on your own and post your answers in Google Classroom. So next, let's do question number 6.